Good morning, evening, afternoon, whatever time it might be that you're watching this. We are going to go over finding the domain of a function. Now, we have already gone over this in chapter 1.1, but this worksheet here is going to go a little bit more in depth for you on what to really look for when laying out your domain and where your domain exists. So just to go through it, it says finding the domain of a function. The domain of a function is the set of all possible values that could be used as inputs for that function. The domain is the set of all allowable x values, which are your input values, and the range is the set of all possible output values, y values, which are obviously your output values. So in general, we start by assuming the domain is the set of all real numbers. Then there are three main exceptions. So we start out believing it's all real numbers, but we have a few exceptions we have to look at. Exception number one, the function contains a fraction having the input variable in the denominator. In this case, the domain is all real numbers for which the denominator is not equal to 0. So our procedure here is to set the denominator not equal to 0 and solve for x. So in our example here, h of x equals 77 over 4x plus 9. So that is our equation that we're working with here. And what we will do is we'll set that denominator here not equal to 0, because we don't want the denominator to be 0, because if we have a 0 in the denominator, we'll wind up with something that's undefined. Then all we have to do is solve for the x in our denominator where it's not equal to 0, keeping that not equal to 0 all the way through, and we see that x cannot equal negative 9 over 4. Now, the domain is a set of all real numbers equal to not 9 over, or negative 9 over 4. And if we want to put that in interval notation, we're looking at negative infinity to negative 9 over 4 with a parentheses, union with negative 9 over 4 in parentheses, all the way to infinity with parentheses on it as well. So basically including everything but negative 9/4. So if it's in the denominator, we want to set the whole denominator not equal to 0. Only matters if there's an x in the denominator. Now exception 2, the function contains an even root index whose radicand contains the input variable. The radicand must be positive in this case, and so the domain is the set of all real numbers for which the radicand is greater than or equal to 0. So our procedure for this exception is that we're going to set the radicand greater than or equal to 0, and we're going to solve for x. So in this example, we've got g of x equals 56x minus 7 square root 6x minus 11. Now the only part we're really worried about is the radicand part, which is the part under the radical. That's your 6x minus 11. That cannot be negative. It is okay if it's 0, because it's not in the denominator, and we can take the square root of a 0. The square root of 0 is just 0. So that's why we use a greater than or equal to symbol right here. So we set the stuff underneath the radicand, the 6x minus 11, greater than or equal to 0, and then we solve for x. So we added x to the other side. We divided by 6, we see that x is greater than or equal to 11 over 6. And if I want to write that in interval notation, I'm going to write it as 11 over 6, comma, infinity. And I'm using the bracket here because it's perfectly fine if it's equal to 6. That's why we say greater than or equal to. Now, exception 3 says the domain is limited by the problem situation. Now, we didn't necessarily cover this very well in chapter 1.1. That's why we're going back and covering it here in this domain worksheet. Now, in our example, it says the amount of money lost by playing Alfred's self-adapting slot machine is a function of the number of quarters gambled, and Alfred claims that the loss can be approximately modeled by the function f of x equals 300 minus the square root of 90,000 minus 3x dollars, where x represents the number of quarters gambled, and we want to find the domain of the function f. So we know from our other exceptions that we really need to worry about this radicand part, right? Because we can't have a negative here. So that's what the first thing we do. We take it and we set it greater than or equal to 0. We solve for x. We see that x has to be less than or equal to 30,000. Now something to notice here, if you didn't catch it while we were solving through, is that we had to divide by a negative 3 here, which caused our less than or equal to or greater than or equal to sign to switch. Okay, remember, anytime with inequalities, if you divide or multiply by a negative, your inequality sign is going to switch. Okay, so right now we are limited to x being less than or equal to 30,000. This suggests that the domain is negative infinity to 30,000. However, because it's a word problem here, we have some other assumptions that are kind of made, right? So the first one being highlighted here is we can't gamble a negative number of quarters, right? Kind of wish we could, right? Kind of wish I could put nothing in and get something back, but we can't gamble a negative number of quarters. So we can only really start at 0. We can gamble no quarters, that's fine. But then we have to kind of start thinking ahead too. So it's not going to be necessarily 0 to 30,000. That's not quite right either, because this isn't quite right either, because I can't gamble a half of a quarter, or a quarter of a quarter, or a third of a quarter. I can only gamble whole quarters. So our domain here really is 0, 1, 2, 3, basically all whole numbers from 0 up to 30,000. So we can write it just like they did over here, 0, 1, 2, 3, dot, 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 29,999, 30,000. That's perfectly fine. Or we can write it in a little more fancy way and say x such that, that's what the dot dot means, x is a whole number that's less than or equal to 30,000. So you have to be careful about your problem situation here. So we've got some steps that we've got 4 outlisted steps here on how to find the domain of a function. The first thing is we assume it's all real numbers until we figure out otherwise. A lot of times the solution for the domain is all real numbers, and it'll go from negative infinity to positive infinity. But we need to move on to step 2, and we need to look at our problem and omit or throw out anything that causes a division by 0. Okay, so if it's got a division in there and we've got an x or another variable in the denominator, we need to figure out when that denominator is 0, and we need to get rid of that number. The next thing we need to do is omit or throw out anything that causes a root of a negative. Okay, so for any positive integer a, and it has to be even, we're going to have to throw out those amounts. Okay, now remember, if your root here is odd, so if this a turns out to be odd, negatives aren't a problem, but if this a is even, that's when we have some problems. And what we're going to do is set whatever's under that square root here, we're going to set it greater than or equal to 0, and we're going to solve for that x. Now number 4 is if the domain is limited by the problem situation, we need to adjust that domain accordingly, just like that previous problem. We couldn't gamble a half of a quarter, couldn't gamble a negative quarter, so that kind of caused us to adjust our domain as well. Now what you'll find in some problems is you'll have several of these, 2 through 4, all combined together. So you'll have a denominator, you might have a square root in the denominator that's actually in a word problem, so you're limited 3 different ways, and you have to account for each and every one of those ways to finally wind up with whatever you haven't omitted in your domain. So we've got some additional examples here that I'm going to go through, and then we have some practice examples, and I'm going to let you go through those on your own. But let's get through these additional examples. So A says f of x equals 8x to the 7th plus 333x to the 4th minus x minus 5 pi squared. Now we have to remember here that pi is just a number, 3.14, etc., etc., etc. They've got a lot of digits to pi, right? You can use it on your calculator, but it's essentially just a number. But what I'm looking at, if I go through my 4-point step list here, I start out believing it's all real numbers. I'm going to throw out anything that causes a division by 0. We don't do any dividing here. I'm going to throw out anything that causes the root of a negative, right? I don't have any roots in question A. And it's also not a word problem, so I'm not really limited there either. So because I really have no limitations on this, my domain is actually negative infinity to positive infinity. There's nothing really here that's going to hold me back. If I look at B, I've got the 9th root of 3x minus 5, which is a radicand, but if you'll notice, it's a 9. 9's an odd number, therefore I'm not worried about the square root of a negative because it's odd, and you don't have to worry about it with odds. I don't have anything in the denominator, it's not a word problem, so my domain stays negative infinity to positive infinity. Now when I come into C, I have the 8th root of 3x minus 5. Now that 8's obviously even, so I could have an issue here if 3x minus 5 were negative. So I need to make 3x minus 5 greater than 0, and then I need to solve for x. And I find that x is greater than or equal to 5 over 3. Now, I've intentionally left this piece off here, and what I want you to see here is this equal sign, okay? This equal sign, I'm going to make you decide, or we're going to decide together, if it needs to be a parentheses or a bracket. Now remember that equal sign means it needs to be a bracket. So I'm going to throw my bracket here on that 5 over 3. It's really important because if you get your parentheses wrong or your bracket wrong, you could wind up getting points off of your question, right? If it's equal to, like it is here, we're going to put a bracket. If it's not equal to, if it cannot be that point, that's when we use the parentheses. All right, if we look at D, f of x equals 4 plus 5x minus 2 over the square root of 7 minus 3x. Now we have, this is an example of where we have two of the exceptions we have to take into account, okay? Exception 1 is the restriction that 7 minus 3x cannot be equal to 0, right? So that whole denominator can't be equal to 0, because if that denominator is equal to 0, we're going to wind up with something on the bottom that's a 0, and then we're going to wind up with something that's undefined. So we need to make sure that this bottom part down here is not 0, right? And that other exception is we've got a radicand down there, which means whatever's on the inside of that radicand, that 7 minus 3x, has to be greater than or equal to 0. Now here's where you have to combine the two. Here it can't be equal to, here it can. The can't wins out, okay? If it can't be 0 on the denominator, I'm just going to go ahead and get rid of this equal to part here. And we're going to notice that we wind up with 7 minus 3x has to be greater than 0. And that's our overall story there. We'll back solve for our x here. We get x is less than 7/3. So what we get is a problem that goes from negative infinity all the way up to 7/3, but is not equal to it because it'll cause the denominator to be 0. Now, like I said, if you notice on this page, we have our exercises here. We've got quite a few of them for you. So 1 through, and we've got quite a few pages of them, 1 through 23. What I want you to do is go through these exercises. Some of these exercises may be on your next test, maybe on your next quiz, maybe even be 1 or 2 in the homework that are the exact same exercise, right? So I want you to go through these, practice on these. The answer key is the very last page of the worksheet, right? So you have all the answers there and the solutions to them. If you get stuck on one, feel free to reach out to me via email. I don't mind at all. I want you to try it first on your own, and if you have any problems whatsoever, you cannot get your answer to match the answer on the final page, send me an email and I'll send you a link to where I go over this entire page on my YouTube page with the solutions so that you can go in and pick out that particular solution that you need to see. Okay, but you should be able to figure most of these out. Most of them are pretty straightforward. Sometimes the word problems can be a little tricky to people, but usually after trying it, checking your answer with the solution key and seeing what the solution key says and then referring back to the question, you can kind of see how the solution key renders that answer. If you cannot, please send me an email. I'll send you an additional link where you can go through and review while I do it step by step in another video. Other than that, I'll see you back here for the next lecture.